So before we start solving a quadratic function by learning how to complete the square, let's just talk about solving a quadratic function and make sure we're all on the same page as far as this is concerned. So when I'm solving a quadratic function, I'm looking for something called the x-intercepts. I'm not looking for the y-intercept. I'm looking for x-intercepts. These can also be called roots. They can also be called solutions. And they can also be called zeros. Okay, zeros are what your calculator calls them, if you want to use your calculator to calculate them. And we'll look at that also. When I'm finding x-intercepts, I typically write it in an ordered pair, and we all know that the y is 0. When I'm finding what are called zeros, I put them as an ordered pair, so whatever the x is of the x-intercept. When I'm finding a solution, I'm just finding out what x is. I just need to say what the solution is, and a root typically is that way also. Now, looking at these graphs below, this graph goes through there, there, and there. Those are solutions. We're going to be looking at graphs that look like that. So I want you to understand that when we solve a quadratic function, we're looking for x-intercepts. But when we solve a cubic or a quartic, we're looking for x-intercepts. So the solutions to this graph here on the left would be -1, -7, and I have no idea, somewhere between 6 and 7. Okay, when we solve a quadratic, okay, yes, this guy crosses the y-axis right there, but that is not a solution. That's a y-intercept. It is not even referred to as a 0. But if you look, where does this guy cross the x-intercept, the x-axis? It doesn't. So this guy has no solutions. He does not cross. Okay? And actually, because of our recent, you have to say no real solutions, because we now know he would have imaginary. Woo, didn't spell that right, did I? Imaginary. There we go. Solutions. Okay, or let's look at something that looks like this. That's a terrible drawing, isn't it? Missed. Okay, this has two solutions at -3 and at +5. Okay, just to do a little bit of a review, these solutions can be put into factors x plus 3, x minus 5. Okay, so now we know what we're looking for. So let's talk about solving by factoring. We did solving by factoring indirectly in class on Tuesday. And let's just factor this guy and remember how we factor. So if you remember, we multiply 2 times -5 and we get -10. And we go into y equals and we put -10 over x in y equals and come up with all the factors. We're looking for the pair in your table that will add to -9. So I'm going to do 1 and -10. 1 times -10 will give me -10, but 1 plus -10 will give me the -9. So I'm going to split the middle with those two factors. And I get 2x squared, but instead of the 9x, I'm going to do plus 1x minus 10x minus 5. The first difference you should see as we're doing these is these are set equal to 0. When you're solving quadratics, they must be set equal to 0, and I'm sure you know that from the past couple days in class. If I want to graph them, they would be set equal to y. Okay, so y equals is graphing. If there's 0, then I want to solve. So I'm now going to put these into those groups that we did when we're factoring. In that first group, the only thing it has in common is an x, leaving me 2x plus 1. And in the second group, I have a minus 5, leaving me 2x plus 1. So my group is the same. What's left is x minus 5. And I have factored, but how does factors, this should look just like the worksheet that we did in class on Tuesday. How do these give me my solutions? How do they give me my x-intercepts? Well, we know this will cross at positive 5, 0, but that happened because I'm multiplying two binomials here together. If this guy equals 0, let's find out where it equals 0. I'm going to set it equal to 0, and I'm going to add that 5. So if I plug 5 into here, and I do 5 minus 5, that's 0. 0 times anything, I don't care what this is going to give me 0. So 5 would be one of my solutions. So I'm just going to do the same thing here. I'm going to set that factor equal to 0 also, which means I also have a solution at x equals 1/2. If I was asked to write these as ordered pairs or as x-intercepts, I would write them as 1/2, 0 and 5, 0. So I went ahead and put in the original quadratic, and this is the graph that I get, and you can see that it does cross at 5, 0, which would be this solution right here, 5, 0. And this looks like it's 1/2, 0. Now I wouldn't be able to guess, but it does look like it is negative 1/2, 0 right there. So here is solving by factoring and also solving by graphing. I could have originally put this in and just kind of seen where this goes. The calculator can calculate these by using two different methods. The one that's most popular is to go into Second Calc and do number 2, which is, whoops, white over that isn't going to work, 0. Okay, I prefer another way, which we'll go into in a minute. So let's try to solve this by those two easier ways. The first thing, remember, this has to be set equal to 0. So the first thing is I've got to move this 1 to this side. So I'm going to get x squared plus 4x minus 1 equals 0. And I'm going to try to factor 1 times negative 1 gives me negative 1. And I need the pairs that will give me positive 4. Well, there's no way anything multiplying to negative 1, which would be 1 and negative 1, if it will add to 4. So this is not factorable. Let's also look at a picture. Here this is as a graph, and you can see where your x-intercepts are. They're right here, but that doesn't go directly through negative 4. And right here, which is a little bit right above 0, but it doesn't, I can't guess it. And if I'm looking at the table of this graph, which I put into y equals, I know I'm looking for where y equals 0. Those are where my x-intercepts are. And I can see that right in here, there should be a 0, and right in here, there should be a 0. Let's make sure you understand why. If my y goes from negative 1 to positive 4, I pass 0 on the way to 4. The same thing here. If I go from negative 1 to positive 4, I pass 0 getting to that positive 4. So I know somewhere in between negative 5 and negative 4 is a 0, somewhere between 0 and 1 is a 0, but not factorable. So how am I going to find this? So what do? We complete the square. And in referring to it, I'm going to call it complete the square, but I will write it as CTS, complete the square. The first step we're going to do is we're going to actually move the c to the other side. Yep, that's going against everything that I said first, where I said setting it equal to 0. But to complete the square, I've got to move the c to the other side. And notice, I'm leaving a pretty big gap here. What I'm going to do now is I'm going to create a perfect square trinomial. And we looked at these when we were factoring. Perfect square trinomials factor into a binomial squared. And we're going to kind of go backwards. So in order to do that, I'm going to take b, I'm going to divide it by 2, and I'm going to square it. So I'm going to take my b and divide it by 2. Then I'm going to take that and I'm going to square it. And this random number is the number that will create a perfect square trinomial for me. So I'm going to add it right in here. But we all know that whatever I do on the left, I do on the right. Now I know that this side, I've just created a perfect square binomial. And if you remember back from factoring, if this is a perfect square, which is x times x, and this is a perfect square, which is positive 2 times positive 2 will give me this positive in the middle, I can create a binomial squared. And one of the easiest things to remember is that this 2 is taken directly from b divided by 2. So this number right here is always b divided by 2. Now, I want to solve this. So in order to solve this, what I would do is I would now take a square root, because I know a squared and a square root will cancel each other out, so all I'll have left over here is x plus 2. But on this side, since I'm taking a square root, I'm going to have plus or minus radical 5. I'm solving for x, so I'm now going to subtract 2 from both sides. Now, we talked about this. I can't add or subtract square roots unless they match. These don't match, so I'm going to put my constant in the front and my radical in the back, and that would be my answer. If I want to put them into x-intercepts, I'm going to have x plus the square root of 5, y is always 0, and x minus the square root of 5, y is always 0. So let's complete the square here. Remember, our first step is move C. So I'm going to subtract 81 on both sides. And I'm going to get x squared minus 24x. Leave that space equals negative 81. I'm now going to do the second step of taking b, dividing it by 2, and squaring it. And that magic number is the number I add to both sides. I want to create the binomial squared. So this will become x squared. I want to create a binomial squared, and don't forget that this number right here comes from b divided by 2. So that negative 12 just plops right in there. And negative 81 plus 144 is 63. The square root both sides. And I'm going to get x minus 12 equals plus or minus the square root of 63. And I'm going to add 12 to both sides. 12 plus or minus the square root of 63. I always want to double check to make sure 63 can't simplify. I know that will... Oh, look at that. I'm going to upside down factor tree it, and I find a pair. That's one pair of 3's. So this guy will become one pair of 3. That 3 will come out and multiply by the 1, and then the 7 will have to stay inside. And so I have x equals 12 plus or minus 3 radical 7. If I were to put 12 plus 3 radical 7 in the calculator, I'm going to get 19.937. Again, we round to 3. 12 minus 3 radical 7, and I'm going to get 4.063. I always like to do this because now I'm going to check this and make sure that it looks like that's where it's crossing. And I'm going to go back to the original. And I'm going to make sure that it crosses really close to 4 and really close to 20. So let's see. Really close to 4. And really close to 20. So we would be right. Here you go. Try one on your own and let's see how you do it tomorrow.